Hello, today we'll solve this problem. We have three blocks, three objects attached to each other as shown in this figure, and the 45 Newton force trying to move this system to the right. M1, M2, M3 given 2 kilograms, 3 kilograms, and 4 kilograms respectively. No friction. So question is calculate contact forces between each blocks, between each objects. So here what you need to do, first we should draw free body diagram. What is a free body diagram? Free body diagram basically we should show all forces acting on each objects. So in this case, no friction, so we don't need to draw all forces in vertical direction, so we will ignore it. Why? Because this system, this block moves in horizontal direction, so that's why we need only horizontal forces. So let's start from the first object. Let's draw it. M1. We know that 45 Newton is trying to move it to the right. Since we have a second object, second block at the right side, of course, and there is a contact between first object and second object, it means there is a contact force, or normal force, sometimes we call it direction force. The name is not important. So contact force. And this force is trying to stop. Yes, it's like friction for the first object, because it's friction, it's resistance. So we can draw in this direction. To the right we have a F1. This is contact force between M1 and M2. That's all. There is no any other forces in horizontal direction. So now we can write Newton's second law for this object. So resultant force F minus F1 equal to MA, M1A. Now let's draw the second object, M2. So the same contact force F1, which is trying to stop the first object, will try to move the second object. This is due to the Newton's third law, action reaction, let's say. So same F1 will be directed to the right for the M2, for the second object. And by using the same logic, there is a contact between second object and the third object. It means there is a contact force, let's call it F2, which is trying to stop the second object. Now let's write Newton's second law for the second object, F1, which is trying to move it to the right, and minus F2, which is trying to stop the second object, equal to its own mass, which is M2 times acceleration. They have the same accelerations. Why? Because if you move the first object for 1 meter, there is no way second object and third object, they also will move for the 1 meter, same distance they will cover. It means at any time their velocity will be same, and at any time their acceleration will be same. Now we have a second equation. Now let's draw free body diagram for the last one, for the third object. Here we have a M3, third object. F2, which is trying to stop the second object, will move third object to the right. So F2 will be directed to the right. There is no any friction, so that's all. In horizontal direction we have only one force for the last object. So due to the second law of Newton's second law, we can write that F2 equal to M3A. So as you see, we have three equations. And how many unknowns? F1, F2, and acceleration is unknown. Yes, three unknowns. So we have three equations. It means we can solve this problem. So let me write these three equations separately. F minus F1 equal to M1A. F1 minus F2 equal to M2A. Then last one, F2 equal to M3A. First equation, second equation, third equation. So now let's add these three equations. So as you see, F1 will be cancelled, F2 will be cancelled, yes. If we add 3 equations, so at the left side we have only one F, at the right side we have M1A plus M2A plus M3A. So from here we can find acceleration. Times A. F was 45 newtons, 2 kilogram, 3 kilogram, 4 kilogram times acceleration. From here acceleration equal to 45 over 5,9. So answer will be 5 meter per second square. This is acceleration of the system. Now question was contact force between objects. Yes. So now we can come back to the first equation. F minus M1A equal to F1. So F1 equal to 45 minus 2 kilogram times 5. F1 equal to 35 newtons. So this is contact force between first and second object. Now we can use last equation to find second contact force. F2 equal to M3A. So M3 4 kilogram times 5. So this contact force will be equal to 4 times 5, 20 newtons. So this is a contact force between second and the third object.